Alrighty then. Let's try that again. I forgot to turn the mic on last time. So, here we are. We're now in space weather mode and earthquake prediction. So, basically, I've just started an audio overview uh, from these 10 documents. Technically, it's 9 because I uploaded this one twice. And it's about the aura of intelligence, which is taking the idea of building digital twins of body and mind from the Kundalini chakra idea of Hinduism and Buddhism and some other philosophies about having 7 energy centers, and then surrounded in my aura design, there's a sphere that surrounds them, and that sphere has data applied to it in virtual reality. So when you're looking at from inside looking out, you have all your stellar constellations, and when you're outside looking in, you can apply maps of like the map of the Earth or map of a star, map of spherical celestial bodies. And so it's about how to use artificial intelligence and real-time data and historical data to map complicated interacting systems that are confirmed on blockchains, data sovereignty, to so that we can understand things that we normally wouldn't be able to understand, to essentially learn how to predict earthquakes, learn how to predict volcanic eruptions, learn how to predict long-term weather patterns and unknown unknowns, the long-term catastrophe patterns of the Earth, because there are cyclical patterns that we haven't totally unlocked and we need to prepare for. So, there's a 48-minute audio overview, and it's basically going to go through an analysis of this mind map. So, 8 core parts of VR aura development: core concept and vision, symbolic code in vector space, which is machine readable AI code, 7 nested torus, like donut shapes, which are relative to your chakras, and then object-oriented programming, edges, faces, colors, lines, and relational data tables, vector space, digital twin of human consciousness, human-centric natural language. That's probably the most complicated part in it. Well, then again, we'll go through deconstructing the toroid, tagging data, coloring edges, faces with because of specific data and meaning, vector space visualization, interactive user interface panels, machine learning, VR scene inspections, the whole kit and caboodle. Then how to turn it into virtual reality space, how to apply functions and features for data management, tracking your user interactions so that it evolves with you over time. Yeah, it's pretty complicated. And one more before we get to the space weather stuff. The goal train is to train ourselves and AI agents in simulated environments to understand complicated things that are beyond our day to day. And we might be able to sense in like a sixth sense, but most of us dismiss the sixth senses and higher senses as woo woo. So we're looking at how to use data processing, blockchain, and provable mathematics to prove or disprove etheric concepts, so that we can have a safer, happier, more joyful world and learn more, so we can get better at life. Yeah, how to initially set up things, define these agents, dynamic simulations, expanding all these crazy things through life stages, growing them up like humans, but with infinite capacity. Or, well, not quite infinite capacity. It's relative to how much computer architecture per time segment we can allocate with our limited energy and, while we're in a monetary system, monetary budget. Uh, Function callers, fine tuning specific roles, mixture of experts, how they're all coordinated, real time adaptation and learning, obviously security, privacy, and keeping a human in the loop, because we don't want the AIs just running off with the fairies and taking over. Training mixture of experts and basically configuring teams of AI agents to save the world with us and not take over the world. Multi-agent chat protocols, different training strategies, education strategies, and managing everything with environment observer, character environment observer, the narrator observer, and run them concurrently with main algorithms so that it's coherent and story driven, so we can understand and zoom in. But now we go to the space weather stuff. This is what the main GG is: immersive extended reality, virtual reality, or augmented reality. So different peripherals allowing us to dive into these complicated things and see them in human understandable formats rather than computer code or nonsense. So you can essentially show it to your grandma or show it to a primary school student and they'll be able to cotton on pretty quickly. Education and real-time news, modular and future-proof Unity system, cross-platform support from putting your mobile phone in a cardboard VR and having being able to see virtual reality, up to the highest, most expensive systems, real-time scientific data streams coming in, AI-driven dynamic content with narration, alerts, multi-dimensional from 2D, 3D, 4D simulations and visualizations, workflow for rapid content production, natural language, news formats for emergencies and education coming out automatically through AI, visual elements. Oh, there's an outtake there. Like solar activity, geomagnetic conditions, auroral forecasts, space weather impact on technology, or like if you're flying in a plane and you might get a bad dose of radiation or whatever. Viewer interaction, so photos, auroras, that kind of jazz, forecast predictions, visual elements. That's much the same as what was before. Data sources from NASA, NOAA, European Space Agency, loads of places that have public data streams, using computer protocols such as Apache Kafka for streaming, microservices, time series databases for forwards and backwards analysis, in that's basically foresight and hindsight, comparing patterns forwards and backwards when you get new data. Processing alerts, caching, offloading. So when you're in an area where you don't have all the compute that you need, it's still working, and then when you get back onto Wi-Fi, then you get the updates, or you can do the deep compute. Real-time updates and ad-libbing. We've got AI avatars, multilingual narration, sentiment analysis, early warning systems, predictive analysis, educational language customization for age-appropriate dissemination of information. We could really make a crazy rap out of this. One of those science raps. There's so many words that rhyme. multimodal AIs, visual, auditory, moderation, and human in the loop. So essentially, we can have this data model, then all these different formats, pipelines for translating it into an appropriate context and format for anyone, anywhere, depending on who's governing the access. So it could be a university governing the access for university students. Then it's going to come in a pipeline that is either first year, second year, master's, PhD level of linguistics and information, or it could be your 24-hour news cycle that makes it as simple as possible for the everyday person, everyone, everywhere, in whatever language the news is like. So if it's English, Spanish, Chinese, whatever. Having this core essence of all this data computed and then the pipelines coming off it that allow it to be understood at any level. Advanced visualizations and level of detail. So being able to scale the level of detail and distort or exaggerate things like time and distance to make things easier to understand, because the distances of space and time in these kind of long form systems and outer space, they're not easily comprehensible without being able to change the scale. So that's very important. Modular content production pipelines, that's again getting the content out or in, or say you can pipe it into even games, or ancestor simulations, because we're getting into that kind of level of detail. You'd be able to understand more about how hereditary, like lineage of humanity was living. Like when we can map these long-term systems, we'll get to understand that more. And there's more technical stuff about open standards, open source, being multiple users or in these systems at once, whether they're uploading data through secure pipelines or at an event and networking, because there's lots of people looking at it and they all want to know who knows what about what and be able to talk about it at a face-to-face human level. All these kind of abstractions, all considered. Collaboration, version control, localization, and then it gets into like earthquake prediction, feasibility, critical data, seismic hubs, space weather, geophysical, atmospheric, ionospheric. If this, then that, IFTTT. That's how to take these data streams and then look at it forwards and back in hindsight and decide which affects which, or which is non-relative to which, so that we can then start to identify precursors in these complicated things for earthquakes, volcanoes, climate change, infrastructure. What do they call it in insurance? Infrastructure when it's deteriorating or whatever. Public health alerts, because that some of these storms, even solar storms can affect human health. They can bugger up heart monitors and all sorts of things. Pre-seismic anomalies, ionospheric disturbances, radon emissions, animal behavior, seismic foreshocks, water level fluctuations. There's so much stuff that is been understood in hindsight analysis of major earthquakes and major earth changes, but now we've got to pull this all into singular data models to project forward with more accuracy and give early warning, so that people all around the world are not dying unnecessarily because we can predict them. It's really, really, as you can probably tell, it's really difficult to express all of this to average Joe Blows. So I'm trying this new way of expressing this. This is by far and away the most detailed that I've done so far, and I'm obviously standing on the work of other people. I haven't done all of this by myself. I've been deep researching many people's research, along with many other things, but this is about Earth catastrophe systems, the known knowns of what we know regularly happens, the known unknowns, where we know these things happen on long cycles, but we don't really know everything about it. We don't know how to predict them. The kind of hypothetical fringe science that some people see patterns and think that they are long cycles, but mainstream doesn't acknowledge, but should be looked at anyway, because if some people can see the patterns, then and it could destroy civilization or life on Earth, then it should be analyzed, even if that mainstream science calls them kooks. And then the unknown unknowns, like the things that we don't have any clue about but could happen anyway. But if we have the high enough detailed data, we might uncover these existential threats that we have no clue about. And data processing stuff. Oh, we still got a few more. Solar forcing, geomagnetic influence, the lunar tidal forces and how they might affect earthquakes, and emotions and volcanic activity, global models. These hypotheses, how new hypotheses can be put into the system and tested against data constraints. So exactly what I was just saying before, things that might be closely related, I have no idea, like rejected by mainstream science. Like even things like animal analysis, radon emissions. There's so many different things that are pretty much being uncovered as true and relative things, but a lot of people just call anyone looking into this woo-woo loonies. And there's all these things like mineral content and the electrical properties and how much water is there, the core sample, structure, age, low shear velocity zones, and large low shear velocity provinces where there's different electrical properties in the electromagnetic circuit from the sun to the Earth's core and the Earth's core to the sun. Like there's so much complexity in this stuff that we can now start to bring into a singular system, and the aura of intelligence is an overarching thing that I've been trying to theorize and design for over 10 years. And this whole solar system, Earth, weather, life stuff is just the outer shell layer of the environmental digital twin. And so there's all this digital twins of body and mind within that, which are like aged care, education, lifelong learning, entrepreneurial, tourism, travel, immigration, trade, logistics, art, entertainment, fashion, smart homes, climate, disaster prevention and recovery, in-home AI auto farms, historic simulations, existential threats to life on Earth, inner space, metaverse, virtual personalities for pets and interspecies language translation, subterranean cities to basically protect ourselves from these existential threats, and then solar system scale development. So, in 10 sources, there's all this fucking nonsense. And from whatever I've just been gibbering, there's another 48 minutes to go. So, welcome to the deep dive.
What if you could perceive the invisible forces that constantly connect our Earth to the vastness of the cosmos? And what if, by understanding those connections, you could even anticipate the deepest, quietest movements happening, right here within our own planet?
That's a powerful thought.
Imagine having a shortcut to truly being well-informed about the biggest, most complex threats and, frankly, the most intriguing mysteries of our existence.
Yeah.
That's a truly profound idea, isn't it?
It genuinely is. I mean, the very essence of scientific discovery and, well, our preparedness as a species really lies in making the unseen comprehensible.
Right.
And in recognizing the profound significance of sometimes very subtle phenomena.
Welcome to the Deep Dive. This is where we take complex ideas, we stack up the sources, and we try to distill them into essential, actionable knowledge, really custom-tailored for you, our curious listener. Today, we're embarking on a mission to unpack an extraordinary concept, something visionary called an aura of intelligence.
Sounds intriguing already.
It does. And it isn't just a catchy phrase. It's actually the blueprint for a really cutting-edge space weather news and education hub. So, our deep dive today is all about understanding how this aura, as they call it, is designed to help us grasp Earth's intricate place in the universe.
Okay.
And perhaps most critically, how it aims to empower us to prepare for, and maybe even predict, major existential threats to life as we know it.
That's a huge goal.
It is. And it ranges from the known knowns to those kind of fringe science edge cases, and even the truly unknown unknowns. It's about recognizing that fundamentally we are all in this together, navigating a universe of constant change.
And to really dig into this, we've gathered an incredible stack of material. Seriously, we're looking at everything from architectural blueprints for incredibly immersive virtual reality environments to intricate discussions on the structure of advanced AI agents and the real-time pipelines that funnel massive amounts of scientific data into this system. At its heart, we're talking about building what really amounts to a digital twin of human consciousness.
A digital twin of human consciousness, that phrase alone.
It's ambitious. The ambition is staggering. To visualize and understand everything from, say, dramatic solar flares scorching across the sun to the deepest, most subtle tremors rumbling far beneath our planet's surface.
So what does this truly mean for us? I mean, how does such a system actually begin to unravel these cosmic and terrestrial mysteries, making them accessible, actionable?
Right, that's the key question.
Let's unpack this step by step and explore how we can go deep in understanding our incredibly interconnected world. The aura of intelligence. A digital twin of consciousness. All right, let's begin at the very core of this visionary system, the aura of intelligence itself. Now, the name might sound almost mystical, right?
A little bit, yeah.
But at its foundation, it's actually a highly advanced framework for both understanding and, importantly, interacting with truly immense amounts of data. The central, maybe groundbreaking idea here is that it functions as a digital twin of human consciousness. Think about that for a moment. What does it genuinely mean to replicate the intricate, intuitive, often nonlinear ways our own minds process information?
It's a huge challenge. It's not simply about creating a fancy database,
Exactly.
It's an ambitious attempt to mirror our brain's incredible capacity to intuitively link disparate pieces of information, to recognize subtle patterns across vast data sets, and even to experience those sudden aha moments of insight that lead to scientific breakthroughs.
Right, like those moments of intuition.
Precisely. Imagine if this digital twin could process all the world's scientific data in a way that mirrors our own curiosity and pattern recognition, but, at an astronomical scale and speed.
Wow.
It could potentially uncover connections that would take human researchers decades, maybe centuries, to find. It's about augmenting, I think, not just automating our collective intelligence.
Augmenting, not automating. I like that distinction.
And what's truly fascinating is how this incredibly abstract concept is given a concrete, vivid visual metaphor within a 3D digital space.
Okay, so how does that look?
Well, our sources describe it as a nested toroidal structure. Now, if you're visualizing a torus, think of it simply as a donut shape.
Okay, a donut. Got it.
So this is like a series of stacked, interconnected donuts forming these highly organized layers of information. Initially, it's composed of 7 nested tori.
7 of them.
Yes, 7. And each of these tori represents what the developers refer to as chakras, or maybe just distinct levels of data, each assigned specific colors.
Interesting terminology. Chakras.
It is. For example, the red torus is conceptually equivalent to the base chakra. This particular torus is designated to hold a foundational layer of data specifically: early human body, mind, activity, observations, environment, and observer narrative.
So really grounding it in human experience from the start.
Exactly. It suggests a grounding of all this complex knowledge in fundamental human experience and perception.
And it's not just these stacked rings floating in isolation, is it?
No. This entire geometric structure is encapsulated by a translucent geodesic sphere inside a cubic volume.
Okay, so a sphere within a cube surrounding the donuts.
Right. It creates this powerful visual impression of a protective or encapsulating field, almost like an energetic envelope surrounding this core data. It gives it a sense of wholeness and containment.
That makes sense visually.
And the whole thing exists within what's called a volume of vector space. Now, for those of us who appreciate the underlying technical genius, this is where it gets truly intriguing.
Lay it on us.
The edges, faces, colors, and lines of this elaborate geometric structure, they're not just pretty visuals, they are directly equivalent to tables of information in relational databases.
Wow, okay, so the geometry is the database structure, visually.
Precisely. It's a direct, intuitive visual mapping of data, allowing you to literally see the relationships between different pieces of information in a spatial way. It's quite brilliant, really.
That is brilliant.
And this vector space isn't just static geometry that holds information. It's dynamically linked to machine learning algorithms and both long-term and short-term memory embeddings.
Ah, so it learns, it adapts.
Exactly. This implies a living, breathing data structure that doesn't just store information, but actively processes, evolves, and adapts with it, mirroring the dynamic and associative functions of human cognition.
So it's a fundamentally different way to interact with data, moving beyond, flat spreadsheets.
Totally, into a truly spatial and conceptual understanding.
Exactly. Okay, so if this is a digital twin of consciousness, and this dynamic data structure, how do we actually get our hands on this data? How is information mapped and manipulated within this aura?
Good question. The sources talk about tagging geometry with data. This means you can actively color faces and edges and use vector space visualization to represent different data points or even complex relationships.
So you could see patterns just by looking at the colors change on the shape.
Potentially, yes. Specific vertices or entire sections of a torus can represent particular data types or categories, allowing for an incredibly intuitive visual organization and exploration of complex information. Imagine seeing a specific color ripple across a torus, immediately signifying a critical change in a particular data stream, like, say, solar wind pressure.
That's powerful visualization.
And to facilitate that interaction, we're talking about sophisticated VR tool menus. These are far from your typical flat, screen-based interfaces.
I did in the space.
Exactly. They are interactive elements seamlessly integrated within the virtual space itself. These menus empower users to quickly embed new information by connecting them into strings and loops and other variables.
Okay, embedding new info directly.
Yes, and what's absolutely critical here is that these actions are not just cosmetic or superficial. Every interaction generates higher dimensional vectors and leaves a meticulous trace address record in their associated tables.
Ah, so there's an audit trail.
A comprehensive, auditable historical log of all interactions and data modifications. This ensures transparency and repeatability in scientific exploration. It's like leaving digital breadcrumbs through your thought process within this digital twin.
Okay, here's where the truly immersive, hands-on part comes in, right? The VR interaction system isn't just for viewing.
Not at all. It actively enables users to manipulate and add data points or vectors in real time within this 3D environment. But beyond simply adding or changing data, the system allows for something incredibly powerful. You can pin your favorite or commonly used sequences of interactions directly within the virtual space.
Pin them, like bookmarks for actions.
Exactly like that. These are represented by VR interactable objects. So if you've performed a complex series of data queries, analyses, or visualizations that you want to revisit or share, or perhaps even automate,
You just click the pin?
you just activate one of these pinned objects to replay a sequence. And the system provides immediate and rich visual feedback, like highlighting or animation, to show you exactly what's happening and how the data is being transformed.
That's very cool. Makes complex analysis repeatable.
It does, and the underlying architecture for this robust functionality involves precise C# code structures, the backbone of Unity applications. Things like modules called interaction, sequence, user sequence manager, interaction recorder, and pin controller.
The technical nitty-gritty.
Right, but these ensure not just stability, but also repeatability and shareability of complex actions within this immersive environment. It's a deep level of programmatic control over a highly abstract data model, transforming personal discoverers into reusable, collaborative tools for the entire scientific community. 2. The Space Weather News Hub. Real-time insights for Earth and beyond.
Okay, we've just explored the fascinating fundamental architecture of the aura of intelligence, this groundbreaking digital twin of consciousness. But how does this profound abstract framework translate into practical real-world tools? Tools that help us understand and prepare for the very real forces that shape our existence.
Right,
Exactly. And that's where the Space Weather News Hub comes in. One of its most critical applications, it seems. It's designed as an immersive XR, meaning both virtual and augmented reality platform.
XR, got it.
Specifically for space weather education and real-time news, all built on the powerful Unity development platform.
Okay, and what's genuinely impressive about this hub is its sheer breadth of reach. This isn't some niche tool confined to high-end research labs,
That's important. Accessibility.
Hugely important. It's designed for exceptionally broad device support. Imagine it reaching low-cost mobile VR in classrooms through simple Google Cardboard setups, 3DUF headsets, and Android builds.
Wow, cardboard even. That's really democratizing it.
Absolutely crucial for global educational access and, democratizing scientific understanding. Then at the other end of the spectrum, it scales all the way up to high-end VR/MR headsets in research labs, supporting devices like the MetaQuest 3, PC VR systems, Apple Vision Pro, and even future HoloLens 3 devices.
So from a student in a classroom to a top astrophysicist.
That's the goal. Everyone can access and interact with this vital information.
That truly highlights incredible adaptive delivery. It's not just compatible with various devices. The same core code base intelligently detects the environment and adjusts content delivery in real time. Yeah. So it can utilize performance-enhancing techniques like foveated rendering on a MetaQuest for optimal performance, and then deliver super sample textures for the ultra-high resolution and fidelity of an Apple Vision Pro.
Tailoring the experience.
Exactly. It ensures a consistently smooth, visually rich, and optimal experience, regardless of the hardware you're using. It's really a testament to thoughtful engineering, making sure accessibility doesn't come at the cost of quality.
And they've put significant thought into a seamless user experience across this incredibly diverse range of hardware. The system leverages Unity's XR Interaction Toolkit, or XRI.
XRI, okay.
For standardized device-agnostic interactions. This means whether you're grabbing virtual objects, pointing at UI elements, or teleporting around the virtual space, the interactions feel natural and consistent regardless of your headset.
Consistency is key for usability.
Definitely. And crucially, the platform adheres to the OpenXR standard. This is a fundamental detail for ensuring broad compatibility with virtually any new XR device that emerges onto the market. This commitment to open standards kind of future-proofs the system and ensures its longevity.
Okay, so we have this incredibly adaptive and broadly accessible platform. Great. But what about the data itself? How does this hub deliver real-time insights into what's happening both within our Earth and far beyond?
Right, the lifeblood of the system.
This is where the real-time data pipeline and visualization capabilities come into play, I assume.
Absolutely. The hub is designed to ingest a truly diverse and comprehensive set of live scientific data streams. It acts as a direct conduit from the cutting edge of research.
So what kind of data are we talking about?
Well, for space weather, we're talking about pulling live data directly from key monitoring satellites via NOAA and NASA APIs.
The big players.
Exactly. This includes critical measurements like solar wind data from DISCO VR and ACE satellites telling us about its speed, density, magnetic field orientation, the works. We also get real-time sunspot numbers, which are indicators of solar activity, and GOES X-ray flux readings, which specifically track solar flares.
Okay, core space weather metrics.
Yes. Beyond that, there's geomagnetic data gathered from ground magnetometers, such as the KP index, which measures disturbances in Earth's magnetic field.
So ground truth as well.
Right. Ionospheric data includes total electron content, tech maps, and ionosonde readings, vital for understanding how the upper atmosphere is affected, which impacts communication and navigation.
Ah, right, the practical impacts.
And crucially, for Earth-based insights, it pulls in remote sensing data like INSAR for detecting ground deformation.
INSAR, that's the satellite radar technique.
Yes, very precise. Also, real-time radon sensor readings and comprehensive earthquake catalogs from the USGS. It's an exceptionally comprehensive data ingestion strategy, really bringing together disparate fields to paint a complete picture.
That's a lot of different data streams to manage.
It is. And supporting all this is a truly robust back-end infrastructure. It utilizes Apache Kafka as a central event streaming platform.
Kafka, okay. Heard of that. High throughput.
Exactly. Ideal for handling high-throughput message brokering, basically. It's like a super efficient postal service for vast amounts of data. For storing all that time series data that changes over time, it leverages InfluxDB, a database specifically optimized for such workloads.
Time series database makes sense.
And for efficiently fetching all those external APIs and pushing the data into Kafka, they use lightweight Python or Node.js services. This ensures the data is collected and made ready for processing with minimal latency.
Keeping it lean and fast.
Furthermore, there's an optional but incredibly powerful data processing layer that can incorporate advanced frameworks like Apache Flink or Spark streaming.
For real-time analysis.
Precisely. This layer is designed for real-time analytics and alerts. So the system can, for example, detect a coronal mass ejection, a CME as it happens, and trigger immediate alerts without delay.
Instant warnings. That's critical.
Very. Unity then pulls this live process data into the XR environment, either via web API polling, using Unity web requests for regular updates, or for truly immediate updates, it uses a real-time push system with WebSockets or a socket.io client.
Push updates for immediacy. Okay.
This ensures that the immersive visualizations are truly live, responsive, and reflect the most current scientific data available.
So with all this data flowing in, what do these immersive visualizations actually look like? How does this information come to life around you in the XR environment?
Okay, this is where it gets really cool. Imagine dashboard panels that float around you like holographic heads-up displays.
Like in sci-fi movies.
Pretty much. Showing numeric and gauge metrics for things like solar wind speed, sunspot number, or the KP index. And these aren't just numbers, they're often color-coded for severity, giving you an instant visual cue of current conditions.
At a glance status.
Exactly. But the experience gets much, much more dramatic. You'll find yourself interacting with a dynamic 3D Earth and Sun visualization. The Earth model isn't static. It can actively display real-time auroral ovals based on the NOAA ovation model.
So you can actually see the aurora forecast visually on the globe.
Yes. Or show intricate ionospheric maps, or plot glowing dots representing earthquake locations across the globe. The sun itself can display live solar imagery, or even animate dynamic light effects triggered by actual solar flares.
Wow.
What's truly fascinating is how otherwise invisible phenomena are made strikingly visible through magnetosphere and solar wind visualizations. Imagine seeing semi-transparent meshes or field lines that dramatically change shape in response to solar wind pressure.
Visualizing the invisible shield.
Right. The system uses exaggeration to make these subtle yet immensely powerful effects perceptible to the human eye, transforming abstract physics into a tangible experience.
That exaggeration technique sounds key to making it understandable.
It really is. And when it comes to those solar flares and CMEs, they're not just abstract data points. You witness animated eruptions directly on the sun.
You see the eruption.
You see it. And coronal mass ejections are depicted as immense billowing clouds moving directly towards Earth. Now, to make a journey that typically takes 1 to 3 days comprehensible in real time.
Yeah, how do they do that?
The system cleverly uses time compression, animating an entire 3-day event in just maybe 10 seconds of animation.
Speeding up time. Smart.
Similarly, auroras and atmospheric effects are visualized as glowing and dancing shaders over the polar regions, exaggerated for visibility, and could even be overlaid directly into your physical room if you're using an AR headset.
Seeing the aurora in your living room.
Potentially, yeah. The ionosphere in tech, total electron content, are vividly shown as a color-changing shell around the Earth. shifting from maybe a calm blue to an alarming red to indicate disturbance, often flashing with wavy patterns to denote activity.
Visual cues for atmospheric disturbance.
Right. For seismic and geological data, ground deformation is powerfully exaggerated by displacing the terrain mesh upwards, giving you a tangible sense of land movement.
So you could actually see the ground bulge slightly.
In an exaggerated way, yes. Fault lines are clearly drawn, and radon spikes might cause specific areas on the map to glow or pulse, indicating heightened activity.
Okay, multiple indicators visualized.
And crucially, data overlays and labels provide immediate context and understanding. Annotations like CME shock front or radiation belt, and you can toggle between simplified and highly detailed views using a level of detail or low system for information display.
So you can control the info density.
Exactly. This ensures the information is always digestible, no matter your level of expertise.
Okay, beyond just visualizing real-time data, this hub takes a giant leap forward by integrating advanced AI for dynamic news and early warning. Tell me about that.
Yeah, this is really forward thinking. Imagine a virtual AI newsreader powered by a sophisticated large language model, something akin to GPT-4.
It's an AI anchor.
Pretty much. This AI can automatically generate compelling news scripts based on live data and a vast array of global news sources, creating, for example, a concise 5-minute news update about today's space weather.
Wow, automated news generation based on live data.
Exactly. It means you always have the most current information, presented clearly and concisely, and it goes beyond pre-scripted updates. The AI can actually ad lib in real time.
Ad lib. How does that work?
If you click on a specific data point within the VR environment, say a sudden spike in solar wind speed, the AI can instantly generate a short, on-demand explanation. Something like, this spike in solar wind speed is primarily due to a coronal hole high-speed stream originating from the sun's polar region.
Instant explanations. That's fantastic for learning.
It really is. These LLM-generated scripts are then converted into natural-sounding speech audio via high-quality text-to-speech systems. You know, Google Wavenet, Amazon Poly, Microsoft Azure TTS, Koki TTS.
State-of-the-art TTS.
Right, ensuring a clear and pleasant listening experience. A 3D reporter avatar then delivers the news with incredibly natural lip sync and animation, achieved through tools like the Oculus Lip Sync SDK, Rhubarb Lip Sync, or Unity's Timeline. It makes the virtual anchor feel genuinely present and engaging.
Bringing the AI to life visually.
And what's even more powerful for a global audience is the multi-language narration capability. The system supports full localization.
So it can translate on the fly.
It can prompt the large language model to translate or even rewrite scripts into other languages, like Hindi, for example, and then use corresponding text-to-speech voices that sound authentic to that region.
That breaks down huge barriers.
It really does. It makes critical space weather information, and indeed all the educational content, accessible to virtually anyone on the planet. It's a big step for scientific understanding globally.
Absolutely. Now, what about this sentiment-informed early warning system? That sounds really unique.
It is groundbreaking. It intelligently goes beyond just raw scientific data by continuously monitoring public discourse.
Monitoring social media.
Platforms like Twitter X, news articles, various forms of user-generated content looking for public reactions like panic, concern, or even the spread of misinformation related to space weather events.
So it's gauging the public mood.
Exactly. An LLM performs sophisticated trend analysis on text feeds from places like subreddits or online forums to summarize qualitative insights. This then informs what the news hub should prioritize or emphasize.
Give me an example.
Okay, say the system detects a surge in online queries asking, can this solar storm cause an earthquake? The AI can then proactively address that precise question in its news updates, maybe debunking myths or providing clarifying scientific context.
Addressing concerns directly based on what people are actually asking. That's smart.
Very smart. And this crucial sentiment analysis feeds directly into automated alerts. The system uses AI-driven triggers that intelligently combine real-time sensor data with this social sentiment data to issue comprehensive early warning notifications.
So the alert itself might be shaped by public perception.
Potentially, yes. It's not just a strong geomagnetic storm is forecast. It's an alert that might be nuanced by public sentiment. The sentiment can even subtly inform the tone of the news.
How so?
Well, perhaps adopting a calming tone if people are panicking unnecessarily, or maybe emphasizing urgency if an event is being underestimated by the public.
Wow, tailoring the tone based on sentiment. That's next level.
And predictive analysis is also deeply integrated, leveraging historical data and sophisticated machine learning models to forecast future events. For example, it might predict an 80% chance of a major solar flare in the next 24 hours.
Okay, forecasting.
And the large language model is key here because it translates these complex, probabilistic scientific outputs into clear, concise statements, always with appropriate caveats, to avoid creating false certainty.
Managing expectations. Crucial.
Essential for distinguishing what is a known known from what remains a potential unknown, guiding public and institutional response effectively.
And finally, one of the most powerful uses of these LLMs within the hub seems to be educational customization.
Oh, absolutely. The system possesses the remarkable ability to tailor content to specific user profiles, whether you're a kid, a teenager, a member of the general public, a science enthusiast, or a seasoned expert.
It adapts the content.
It dynamically adjusts the vocabulary, the depth of explanation, the complexity of the presented information. You could simply hit an explain in simpler terms button, and the AI will instantly rephrase the last segment for a lower reading level or a less technical audience.
Adaptive learning in real time. That's a game changer for science literacy.
It truly is, and it extends even further to regional and cultural localization.
Meaning?
Well, imagine an Indian audience, for example. They might be more concerned about the impact of space weather on their rail network or its potential influence on monsoon predictions.
Right, different priorities.
Whereas a North American audience might prioritize information about potential impacts on their power grid or satellite communications. The AI can intelligently insert relevant comparisons or provide context that resonates specifically with local audiences.
Making it relevant locally.
Exactly. Ensuring the content is not only engaging, but also directly relatable and impactful to regional concerns. This dedication to global and personalized educational outreach directly addresses the mission of preparing for threats on both a local and a global scale. It really embodies that idea that, we are all in this together. 3. Unpacking existential threats. Deep Earth and beyond.
Okay, we've spent considerable time exploring how the Space Weather News Hub brings the vastness of the cosmos directly to our fingertips, helping us prepare for events like powerful solar flares and CMEs. But the existential threats we face aren't just from above, are they?
No, definitely not. Some of the most significant challenges rumble deep beneath our feet, within our own planet.
So how does this aura of intelligence help us unlock the mysteries of our own Earth and potentially predict those truly earth-shaking challenges?
Well, this requires a truly comprehensive data integration and analysis approach. It's about correlating diverse data streams to uncover subtle interactions and timings between various Earth and space phenomena.
Looking for those hidden connections.
Exactly. We're really looking for the intricate interconnectedness that could signal major threats, both the known ones and the unknown ones.
This holistic approach seems absolutely critical, not just for the known knowns, like, say, the direct impact of solar flares on satellites.
Right, the obvious stuff.
But also for exploring more speculative, fringe science edge cases, and maybe even those truly unknown unknowns that might emerge from complex interactions.
That's the cutting edge. The core data sets feeding into this Earth-focused aspect are vast and incredibly diverse. We're talking about real-time seismograph data and extensive historical earthquake records.
Building a deep seismic picture.
Right. Providing a deep historical and current understanding of seismic activity. Then there's comprehensive geophysical and geological data, detailed maps of tectonic plate boundaries, active fault lines, lithospheric data, which is information about Earth's rigid outer layer.
The basics of geology.
Yes, but it goes deeper. It even integrates reports from mining companies and deep core samples, extending our understanding to the deepest parts of the mantle.
Wow, mining data too.
Yep. Including enigmatic regions like low shear velocity zones, or LSVZs, and large low shear velocity provinces, LLSVPs, these vast, mysterious areas deep within the Earth that scientists are still trying to fully understand.
Those deep mantle mysteries.
And this extensive terrestrial data is then meticulously cross-referenced with all the space weather data we discussed earlier. Solar wind speed, density, the interplanetary magnetic field, IMF data direction, strength sunspot numbers, solar flares, CMEs.
Connecting space and Earth data directly.
Directly. But it doesn't stop there. It also incorporates a rich array of atmospheric and ionospheric data: total electron content, outgoing long-wave radiation, atmospheric pressure, wind speed, direction, cloud cover, precipitation, radiation levels, aerosol optical depth, specific gas concentrations.
It's an almost overwhelming symphony of data, isn't it? All brought together.
It is indeed, and it gets even more fascinating because it integrates additional indicators that are often considered more, let's say, esoteric or anecdotal by traditional science.
Like what?
This includes real-time radon emission increases from the ground, which some researchers believe can precede seismic events.
Oh, the radon hypothesis.
Unusual animal behavior analysis, things long observed by ancient cultures, precise water level fluctuations in wells and boreholes, thermal infrared imaging anomalies, which can detect subtle temperature changes preceding geological events.
Precursor signals.
Potentially. And even acoustic emission analysis in rock media, basically listening for the faint sounds of stress building in the Earth's crust.
Listening to the rocks.
Yeah. The data processing and correlation happen through the same robust pipeline we talked about. Kafka for real-time streaming, InfluxDB for time series storage, with Python likely doing a lot of the processing and analysis.
Okay.
The system possesses the remarkable ability to merge all this disparate data on a common time axis for advanced correlation analysis, using methods like Pearson correlation and employing sophisticated machine learning models like random forest classifier to achieve predictive capabilities.
So, for example,
It could try to predict earthquake risk based on specific patterns of solar activity. It's exploring those potential, maybe controversial, links. This holistic approach really recognizes that everything might be interconnected in ways we don't fully grasp yet.
And here's where the system's geological understanding gets incredibly granular and impressive. It even accounts for olivine as a special case. Why olivine?
Good question. Olivine, along with similar minerals, is specifically highlighted because their unique properties significantly influence the rheology of Earth's mantle.
Rheology, that's about flow, right? How things deform.
Yeah, exactly. How the Earth's deep interior, the mantle, flows and deforms under immense stress and temperature. These minerals play a fundamental role in driving plate tectonics and, consequently, seismic activity.
So understanding olivine is key to understanding plate tectonics.
It's a major factor. The system actively tracks its distribution and impact, demonstrating an incredibly detailed and nuanced level of geological understanding. It acknowledges the subtle but profound drivers of planetary processes.
Okay, so to truly enable deep understanding of these complex and often invisible forces, the system employs advanced visualization techniques. What are some examples?
Well, one of the most powerful is the use of exaggerated scales, whether logarithmic or nonlinear. This is crucial because it visually amplifies the relative magnitudes and effects of subtle forces that would otherwise be imperceptible.
Making the tiny visible.
Right. For example, minor geomagnetic field variations that might normally seem insignificant can be visually amplified to clearly show their potential impact on seismic activity if such a link exists. This ingenious approach helps make otherwise invisible or subtle phenomena tangibly perceivable and understandable within the VR environment.
Bridging that gap between data and intuition.
Precisely. And for tailored learning and research, there's an ingenious level of detail scaler, or Lodi scaler. This allows users to dynamically adjust the complexity and amount of data displayed.
So you can zoom in or out on the complexity.
Exactly. You can choose to see high-level overviews at low D1 for a general understanding perfect for students or casual learners, all the way to highly detailed analyses at low D5, which would be ideal for researchers who need to pore over every single data point and its intricate relationships.
Information at the right depth for the right audience.
That's the idea. Fostering understanding across the entire spectrum of knowledge. The visualization also incorporates truly immersive 4D elements, with time being the fourth dimension.
Time is a dimension you can control.
Yes. This means you're not just looking at a static snapshot. You can actively play back or even forecast changes over time, observing phenomena like solar cycles unfolding, seismic clusters forming and evolving, or volcanic activity swelling.
Seeing processes unfold.
Yeah, and users can dynamically manipulate 3D models of Earth, its tectonic plates, different atmospheric layers, and even visualize complex magnetic field lines in real time. This provides an unparalleled interactive exploration of complex dynamic systems. It transforms static data into a living, breathing model of our planet.
And there are truly specific visual examples that bring these incredibly complex interactions to life in a way that words alone cannot, right?
Oh, definitely. You'll see solar forcing and geomagnetic influence depicted with vivid arrows showing solar wind direction and intensity, dynamic distortion of the magnetosphere, and clearly highlighted geomagnetic storm areas wrapping around the Earth.
Seeing the solar wind hit the shield.
Visually. For seismological impact, the system renders active fault lines, tectonic plates with dynamic movement arrows, flashing seismic activity dots representing real-time earthquakes, and even visual representations of subtle lunar influence waves on the Earth's crust.
Lunar influence waves. Wow.
Yeah, visualizing those subtle tidal effects. The lunar tidal forces on Earth's crust are made strikingly visible through animated tidal bulges shown as wavy lines, gravitational pull depicted as curved arrows, and areas of heightened stress on fault lines clearly highlighted.
Making the moon's pull visible on faults.
It's attempting to. Atmospheric and ionospheric responses are visualized with distinct atmospheric layers, a glowing responsive ionosphere, solar radiation beams piercing through space, and swirling ionospheric currents.
Seeing the upper atmosphere react.
And for volcanic activity, you can even see a detailed cross-section of a volcano, with external forces arrows dynamically indicating how various forces, maybe tidal, maybe geomagnetic, might be influencing its internal pressure and potential activity. These visualizations are meticulously designed to make highly abstract scientific concepts truly tangible and comprehensible.
What's truly exciting, and perhaps a bit provocative, is that this system isn't afraid to explore fringe science edge cases and even the elusive unknown unknowns through the systematic generation and testing of hypotheses. Tell me about that.
Right, it's pushing boundaries. For instance, one fascinating area it delves into is the Earth-Moon electromagnetic hypothesis.
Okay, what's the core idea there?
This particular hypothesis posits that the interactions between the Earth and the Moon involve significant electromagnetic components in addition to traditional gravitational forces.
More than just gravity between Earth and Moon.
That's the suggestion. It suggests that as the Moon orbits the Earth, it passes through varying intensities of Earth's magnetotail and the dynamic solar electromagnetic field. This influence, the hypothesis suggests, could be impacting tidal dynamics beyond what can be explained by traditional gravitational models alone.
Interesting. Affecting tides electromagnetically.
And what's even more compelling is how this hypothesis extends to include potential effects on vortices such as cyclones and high and low pressure wind cells, theorizing a measurable impact on the formation and behavior of atmospheric vortices.
Whoa, linking the moon's EM field passage to cyclones. That's out there.
It is fringe, absolutely. But if proven, it would represent a truly profound and previously overlooked connection between celestial mechanics and terrestrial weather systems.
Okay, what else? You mentioned radon earlier.
Yes, the intriguing radon-EMF interaction hypothesis. This one proposes that due to its diamagnetic properties, radon gas distribution and its accumulation might be influenced by electromagnetic fields present in the Earth's crust.
So EM fields moving radon around.
Essentially, it suggests that radon, a naturally occurring radioactive gas, might react in subtle ways to changes in Earth's electromagnetic field. Therefore, monitoring changes in these fields could provide entirely new indicators of radon movement,
Which could link back to earthquakes.
which in turn could be used as a novel method to predict seismic activities. It's an innovative, if unproven, approach to earthquake prediction, linking a common gas to fundamental geophysical forces.
Very interesting speculative avenues.
And what's truly ambitious and forward-thinking about exploring these hypotheses is the intention to extend them to reproducing results in a contained plasma environment.
Reproducing them in a lab.
Exactly. Designing laboratory experiments to study how similar electromagnetic and gravitational forces influence plasma behavior in a controlled setting. This bridges the vast scale of celestial physics with the meticulous precision of experimental physics.
Lab testing cosmic ideas.
Allowing for controlled observation and rigorous testing, it's how we systematically move from the speculative to the potentially demonstrable, tackling those unknown unknowns head-on by creating a tangible, testable environment. 4. The brains behind the operation. AI agents and simulation architectures.
So we've explored the incredible scope of data and visualization within this aura of intelligence from the cosmos to the deep Earth. It's mind-boggling. But who or what are the true brains behind this whole complex operation?
Ah, the intelligence engine.
Right. It's not just a fancy VR system. It's powered by incredibly sophisticated AI agents and simulation architectures.
That's correct. The core of this intelligence uses a fine-tuned large language model, or LLM, controller. Think of something highly advanced like Hugging GPT that doesn't work alone.
Okay, an LLM conductor.
Sort of. Instead, it guides and orchestrates what's called a mixture of experts and a suite of AI autogen agents. This is truly next-level artificial intelligence architecture.
Mixture of experts and autogen agents. Explain those.
Right. It's a highly intelligent, distributed, and collaborative system. It meticulously differentiates between various types of agents, each with a specialized role. You have task agents that are designed to execute specific, well-defined tasks, whether that's processing a data stream or generating a specific visualization.
The worker bees?
Kind of. Then there are supervisory agents whose critical role is to review the work produced by the task agents and provide insightful feedback, ensuring quality and accuracy.
Like to control AI?
Exactly. And finally, communication agents facilitate seamless message exchange between all these different AI components, ensuring a cohesive and efficient collaborative environment. It's really an ecosystem of intelligent agents working in concert.
And crucially, there are built-in checks and balances with human in the loop.
Right.
So not totally autonomous.
Absolutely not. That's vital. This isn't a completely autonomous black box. The process is inherently iterative. A supervisory agent diligently checks the task agent's work, and if the quality isn't up to par or further refinement is needed, it sends that work back for revision.
Okay, AI peer review.
But the most vital part of this entire system is the continuous involvement of the human in the loop. Humans are deeply embedded in a discovery process with the human and the function definer to generate all of their functions.
So humans are teaching the AI what its jobs are.
Precisely. Humans are actively guiding the AI in defining its capabilities and objectives. Subsequently, the function caller, another AI component, is trained by humans to organize and prioritize actions, ensuring human oversight and continuous learning.
Keeping humans in control of the goals.
That alignment with human goals and values is absolutely critical, especially when dealing with something as significant as existential threats. It's about combining the best of human insight with AI's processing power.
Okay. To achieve this extraordinary level of sophistication and train these AI experts for complex real-world scenarios, the system employs a unique life simulation framework. What is that?
Yeah, this is fascinating. This comprehensive life simulation provides a dynamic environment for training these AI experts across various domains, fostering civilian, academic, and even corporate excellence. It involves meticulously defining individual agents for different life stages, mirroring human development: baby, toddler, child, teenager, and adult.
Simulating an AI's entire life.
In a way, yes. Each agent is imbued with specific, developmentally appropriate attributes and learning objectives. For instance, a baby agent might focus on sensory exploration, while a toddler would emphasize language acquisition.
Tailored goals for each stage.
Right. Critical thinking would be a core attribute for a teenager and professional expertise for an adult agent. And these agents don't just have attributes, they also have defined behaviors that evolve over time, such as imitation learning in early stages or complex career development as an adult agent.
So they learn and grow within the simulation.
Right. They do. The simulation integrates incredibly dynamic simulation components. This includes time allocation functions that vary by age group, mimicking the natural progression of life. It accounts for daily activities like watching and listening, vital developmental and life stage factors, and even external influences like global world events.
Reacting to simulated world events.
Potentially. The system tracks cumulative experience over time, allowing agents to learn and grow, and even accounts for cyclical and seasonal adjustments, making the simulation profoundly realistic and nuanced.
That is remarkably detailed.
It is. It even includes base formulas designed to calculate an agent's total number of thoughts and words generated in a minute, reflecting their cognitive output and processing speed.
Quantifying AI thought.
Attempting to model it. These formulas are then expanded with sophisticated multipliers for different states, such as casual, normal, urgent, hyper, and even REM sleep.
Simulating AI sleep cycles.
Providing an incredibly nuanced simulation of cognitive output under various conditions. Furthermore, it meticulously develops and integrates various submodels for cognitive development, which incorporates a growing vocabulary and educational content, social interaction, and even physical activity.
Wow.
These submodels are all combined with specific weightings based on the agent's current life stage, ensuring these AI agents behave with a high degree of realism and adaptability, preparing them for increasingly complex real-world challenges.
Okay, beyond the main simulation algorithm that drives these life stages, there's an ingenious advanced observer system. What does that do?
Right, this adds another layer. This system consists of 3 specific extra observers that run concurrently with the main simulation, each providing unique and invaluable perspectives on the unfolding digital reality.
3 different viewpoints on the simulation.
Exactly. The first is an environment observer, which describes the overall simulation environment. This provides a broad, objective context of the digital world. The agents inhabit the setting, the conditions.
The big picture observer.
The second is a character environment observer. This one specifically zeroes in on what the main character or agent observes and directly interacts with within their immediate surroundings. It gives a highly personalized, character-centric view.
The character's point of view observer.
And the third, which adds an incredible layer of richness, is the narrator observer. This observer actively narrates the main character's reactions to various stimuli and their interactions with the environment. It adds crucial layers of storytelling and even potentially simulated emotional depth to the simulation.
A storyteller AI watching the simulation AI. That's meta.
It is. These observers are truly critical because they add additional layers of analysis and storytelling that go far beyond simple data logging. They significantly enhance the depth and interactivity of the simulation.
How so?
Well, imagine trying to understand a complex event in the real world. You'd want a broad overview of the environment, right?
Sure.
A close-up on how a specific individual experiences it, and perhaps even a narrative voice that explains the broader implications or emotional impact. These 3 concurrent observers do exactly that, transforming raw data into a rich, interactive narrative of what's happening within this profound digital twin of human consciousness. It's about context, the why, and how it all fits together.
Outro.
Wow. We've taken a truly extraordinary deep dive today, haven't we? Exploring this visionary concept, the aura of intelligence. It's a groundbreaking system that intricately intertwines advanced virtual and augmented reality.
The XR component.
Pulls in real-time cosmic and terrestrial data from just a multitude of sources and processes it all through these sophisticated AI agents and simulation architectures we just discussed.
It's quite a synthesis, from visualizing the subtle, almost elegant dance of Earth's magnetic field as it responds to solar wind, to predicting potential seismic tremors based on intriguing radon emissions, and even theorizing about the moon's electromagnetic journey through space. This system offers an unparalleled, holistic, and deeply interconnected view of our place in the universe.
It really is designed to reveal those invisible threads that tie everything together.
Seems so.
And it's more than just an impressive technological feat, isn't it? It's a powerful tool designed not just to inform and educate, but crucially, to potentially safeguard us.
Preparedness is key.
It aims to prepare us for threats we can already clearly see and understand, as well as those more speculative challenges, those fringe ideas that we can only just begin to hypothesize about. Think about how understanding these intricate, often hidden connections, made visible and interactive in a system like this, could utterly transform fields from disaster preparedness to lifelong learning.
Education, definitely.
And maybe even influence our personal well-being by simply fostering a deeper understanding, a deeper connection to our world.
Absolutely. Ultimately, it's about far more than just data collection. It's about making the incredibly complex comprehensible and the truly unseen tangible. It's about connecting us more deeply to our planet and to the immense forces that shape it every single day. It truly embodies that idea that, we are all in this together, navigating the knowns and constantly pushing the boundaries into the mysteries.
So as we consider this intricate tapestry of data, intelligence, and immersive exploration, maybe ask yourself, if we can build a digital twin of human consciousness, to map the knowns and courageously explore the unknowns of our world and beyond, what new forms of intelligence might we uncover? Not just about the cosmos, but perhaps even within ourselves.
That's a deep thought.
And what previously fringe ideas about the fundamental nature of our reality might one day become known knowns. through such profound and immersive exploration.
It certainly makes you wonder. We encourage you, the listener, to reflect on the astonishing possibilities of such an integrated system and what it really means for our collective future.
Until next time, keep digging, keep questioning, and keep connecting those dots.
Before the first breath, before the first light, you were the silent witness. Infinity gazing into itself, a game waiting to be played. No up, no down, no left, no right, no name, no sound, only spirals of sight. But the wheel must turn, the currents must dance, and so you fell through the black hole. Sound swirls, stretching, warping, folding, the feeling of falling inward through the eye of the storm, through the silent void, pulled in, pulled down, through the doorway of the womb, and the colors blend, and the shapes scream, and the first forgetting became the first awakening. And the breath, the cry, the world of form, the great unknown, the game is on. The spin of the cosmos, rhythmic patterns emerge, tribal drum pulses, spinning loops. Galaxies spin, stars spin, planets dance, the tide pulls in. Cyclones rage, minds unfold, the fractals weave a hidden world. Above, the ancestors whisper, below the children dream. Between the two, you are here, spinning. Up is down, left is right, light is shade, shade is light. The riddle speaks, the echoes call, the spiral spins, the dice will fall. The code is laughter, the key is play. The game has only begun. The playground of light and shadow, step into the dance of dark and bright. Feel the sun embrace the night. Every move a path unknown, every step the seeds are sown. Do not fear the unknown, for it is in the unknown that the magic of play